So hi everyone, thank you for inviting me to PyData. And today I will talk about what we do at the Prague Data Platform. I think I will do some introduction for people that don't know the project. And I'll show a little case study which is a little bit analytical and a little bit about DuckDB to keep the topic of today. And then there will be some Q&A. But before I start, I would like to know who of you uses Google Maps to search for public transport connections in Prague? Okay. And who uses Lítačka, the app? Perfect. So I'm super glad most of you are already users of the data from our platform. I will try to make this a little more visible. So this is our system that actually aggregates the real-time positions of the public transport, including the calculation of the delays, and provides this data back to the city, so including these third-party developers like Google Maps. And so this is just an illustration of what we are actually doing here. Now, who am I? I'm František. I'm the tech lead for data analytics. And feel free to reach out to us. We have some web pages, and these are the contact details. We are super happy to engage with any developers that are interested and curious to work with the city data, either for the city's advantage or maybe for an advantage of your own project. Please do reach out to us. We have Martin here with the black t-shirt, No I Backup. He's our product manager. You can talk to him and he will hear your thoughts. So some 6 years ago, there was just this, the city of Prague, and no data. Now, there was a lot of data in the city of Prague, and that's why some smart people in the government of the city decided that they would like to build a platform to aggregate the data and make the city a little bit smarter and maybe more livable and make better decisions. That's how our project was born. It's called the Prague Data Platform, or it's known under the brand Golemio. And what it is, it's a central point, central data hub where a lot of the data from different city systems is aggregated, and then it's distributed to the city as analytics, as reporting, but also just further into other systems of the city where the data is needed. This is just to give some examples of different data sources. So we have the real-time positions of the public transport, parking. We have some sharing economy in terms of cars, bikes, these e-scooters, and so on. We have something about climate. And we do have a lot of measurements about like the pedestrian traffic, the bicycle traffic, car traffic, and so on from various sources. Some of them are like sensoric, IoT. Some of them are other places like the Waze application, for example, gives us data to help the city be a bit better. So we are city-owned, that's important to say. The company is called Operator ICT. Some of you know it because it's the developer of Lítačka. It's the central place for the data in Prague. It's a team of really enthusiastic people that want to build better cities. And it's open source, so we want to build this transparency, public money, public code. You can check out the GitLab repositories where we publish most of our work. And also, we do provide a lot of data to the public, which I will talk about in a minute. So who's the audience? Who are our clients? It's the public, because anyone can get a lot more information about the city with the help of the platform. And I will show you the different distributions of data that we provide. But many times it's the domain experts and citizen developers or third-party app developers that just want to get some data from the city and use it for their products, use it in their decision-making. And we are gladly supporting these people to be able to do that. The last thing is, and this is the most important category, it's the city decision makers. People that really make the decisions. It's not us. We just analyze the data and then we work with them to make the best decision that they can. And some of you, I think, would be surprised by how many people in the city actually do decide on data and how well they know their domains. So we are there to help them with some of the technical parts, maybe some of the analytical things that are quite complicated to them, but they do make really wise decisions based on data. Now, what do we offer actually to the public? This is quite nicely summarized on our web page called data.praha.eu. And it's the data portal of the city. And here are some of the things that we provide. These first two things, we are as the developer of tooling for the city to publish data. In the first case, this is like an infographics portal where the city can publish data and just communicate to the public about like what was the budget last year, how many kilometers of bike lanes there are in the city, and so on. This is another tool. It's the catalog of open data. It's again distributed as open source, and there is many institutions currently in the Czech Republic that use it as their own instances of this catalog. And that helps all the individual institutions in the city to publish the open data that they want to publish. So we are not aiming to gather all the data from the city, but giving the data kind of owners the possibility to distribute them on their own. This part down here, it's more something that we really do on a daily basis. And this is like kind of business intelligence for the city, dashboards that we build, usually with some decision makers from the city, and then we provide them to the public. And then this might be the most interesting to you. This is our APIs. So we have APIs that are also built for our clients, but some of them are open to anyone who might be interested in the data. And often this is like live data, almost in real time, that you could use maybe in some of your own projects. This is how the Swagger documentation looks like for the API. Wherever you see open data available, that's something that anyone can access, and the rest is maybe private or on request. And the list is a lot longer than this, but it illustrates the variety. So we have like something about counting bicycles on the bike lanes, and then we have the measurements of pedestrian traffic, and then we have microclimate measurements that you can all access. For the decision makers, we are working on kind of like an intelligence panel. So anybody in the city who decides on certain area gets a mix of their own, data, infographics, dashboards, maps, and then can do the decisions. This is just a couple of topics, but we do work a lot in waste management, so you have some reporting for that. This is about the P+R parking spots and their real-time fullness. And we have something about housing here, about Airbnb flats in Prague. This is a nice example. It's about the fullness of waste bins. We do have 7,000 bins equipped with sensoric devices that measure the fullness. And so I just picked a random bin around the corner from here. We are somewhere here at the moment. And it's a colored glass bin, which is 37% full yesterday night. And you can see the history of the last 7 days. Sorry? Yeah, there was a party here, right? This is used actually to improve contracting with the service providers, but also to optimize the schedules. So if we see some bin being emptied when it's like half full, we consider that as an inefficiency. And when we see some bins being full all the time, we would try to increase the schedule, or the people that decide about this would do that based on our intelligence. And yeah, this is just an example of one of these reports. It turns out that the data platform is really useful for like responding to crises. We worked a lot during COVID, and this is an example from the reporting about Ukrainian refugees coming to Prague and other regions. And the city usually really uses this data to have political discussion, but also make some real-life decisions about the city. And all of this, we do like open source, and we do publish open source, and we work with some of the famous open source technologies. There's many more than this, but I picked those that are more like data related in the stack. So this first part, we have Postgres as our main database, and we have this real-time integration platform which is running on Node.js and RabbitMQ. So this is something we have from the start. And then this is our like analytical stack. We work with dbt to transform the data, Prefect as the orchestration engine, Python to write ETLs and wrangle the data and analyze the data. And then I added DuckDB because I want to show you how we used it on a recent project. Let's get into the case study. But maybe first, are there any questions now? It's like the middle of the talk. Yes.
I was wondering about the sensors in the waste bins. So how do they work? Is it based on weight or some kind of like space use? Or?
It's ultrasound based.
So it like kind of fucks up bats flying.
Yeah, if they fly into the container, they get like really buzzing in their heads. It's basically just like something that sends these ultrasound waves, and then when it hits the waste, it kind of goes back into the sensor, and it's calibrated to the depth of the bin, and that's how the volume is calculated.
Are all those data real-time, or only a few of them?
We work with like real-time and almost like statistical data as well, so it depends on the project. But if you mean the bins, for example, it comes with like 15-minute delay, I think. Yeah.
Sorry, follow-up question. So there is some IoT collector, whatever it is, and then you like using Prefect, fetching those data and uploading them to the like central store, or how does it?
Yeah, this would be an example for the like real-time integration. So it's like Node.js backend that like fetches the API of the sensoric providers. We don't have our own IoT platform, but we interface with the APIs of the providers. Like there is an external company that is building the sensors. Yeah. There was another question, I think.
Yeah, when you mentioned the decision makers use the data, how far to the top does it get? Because sometimes you don't see the wisdom of the data in the decisions.
It's mixed. For example, we worked quite a lot with the former mayor Hrib, and he used data more as a PR, but he did use data, and he was quite like strict in doing that, and he was pretty also a good analyst, I would say, interfacing with us in the discussions. But it's like there are these islands of people that want to work with data and they know how to do it and so on, and then there are islands where I would say people don't have the abilities or maybe they don't have the will to do that. So it's mixed. Yeah.
Is there some trend in that? So which islands are getting bigger?
I mean, we see like more and more engagement and mainly like collaboration between the stakeholders. So from my point of view, it's like improving because back in the days there used to be quite large silos between like one city company and another wouldn't want to provide data to each other. And this is changing quite a lot. So even like the public transport company would be willing to provide data to other institutions in the city, and they were usually very strict in like, it's our data and we only want to use it for us and so on. Yeah.
Do you plan to expand to other cities?
Basically not beyond like our influence, our publishing of the open source and consulting, because we as a company are owned by the city and we are like obliged to work for the city as a client. But there is a lot of requests to us to work for other cities. So we try to help them but not work for them. Yeah?
Would you say that at some point we could replace city decision makers with AI?
I don't know. Maybe you could join us and work on that. That's something they wouldn't like to hear. So we try to treat them with a lot of respect, and I think usually that's a good strategy, and eventually they are willing to let the technologies help them, but we are trying not to scare them in advance. Yeah. Perfect. So let's get into the case study. You saw this real-time system on the public transportation, but now we want to work with the historic data about the delays of the public transport, because the city organizer of the public transport, Ropid, they are really interested in using this data to kind of optimize the system. And actually, this is the first time that somebody has this data at their disposal outside of the specific purpose systems. So for example, there are many systems that allow you to analyze the situation that's happening in real time for trams in the city center, because these operators, they need to work with it. But it doesn't allow you to have different view of the data or extend the period that you want to look at and so on. So there are two interesting use cases that we are working on at the moment. And it's this identification of unusual situations. And then the second thing is more long-term, and it's about gathering evidence to support traffic planning and scheduling of public transport. I will show you what we have at the end, but actually this became more of a technical challenge for us than analytical one. So usually this is our analytical stack. We have data in Postgres, all of them. We transform them, clean them up in dbt, And then at the end, we have a beautiful Power BI report, or we have like Jupyter analysis of whatever the clients are asking for. But now we have like every position, like every message about the position of every vehicle in the whole PID region, which is spanning even further than central Bohemia sometimes. So that's a lot of traffic. And this data is just like too large for us to keep it in Postgres cost efficiently. So we were just like thinking about, okay, this is something new for us. How can we do it? And we are a public company, so we try to save money. And we just wanted to build a prototype and to start gathering the historic data as fast as possible and just deliver some interesting results. And so we decided for this kind of pipeline. This is the real-time system in Postgres. Developers are happy. They don't have to change anything in this system. We offload some the data on a regular basis to Parquet files, which are very like memory efficient and small, but can also be queried. And this data is on Azure Blob Storage, so cheap storage like the S3 or something similar in Microsoft Azure. And that's where the full history is. But then how to actually get to the data, usually you would have some larger like query engine like Spark or something. And again, it's using DuckDB to then get some data for the clients in Power BI. And I decided to just illustrate how simple these steps are in DuckDB. And for that, I will do a little demo. But obviously, live demos are always complicated. So we will see how that works. Okay. All right. So I will not even show you the Python API because I think it's too complicated. And this really illustrates how simple it is. So first challenge, you want to get Postgres exported to a Parquet file. How do you do it? You need 2 lines of code. First one, attach to the Postgres database. This is just to show you something. And then save it as Parquet. I will do it now. The attach will not work because I have like fake credentials here, but it's already attached. So I will query the database. It will not work, but it will work soon. Here we go. Okay, so I just queried a table from Postgres, right? I attached it with DB, and then I asked, and this is interesting, I just said from DB. I don't need to write select anymore in DuckDB. So that's beautiful. So it works. I'm connected to Postgres, and I want to export this table to Parquet file. So I will just run it. And now this will take a little bit longer. So it has to ask the database in the Netherlands and then, convert it to Parquet. But while working on it, I can move on to the next step. So now the next question is, how do I get to the data? It's in Parquet. I want to ask questions now. And this is really simple. I think David already showed it. I will just, write the address of the file and then a select statement on top of it. But we'll wait for this to finish. In the meanwhile, I wanted to relate to what David said. Obviously, you could try to do the transformation from Postgres table into Parquet using pandas, for example. And we did try to do it. but it's just like so memory inefficient that it was just really painful. And then somebody said DuckDB, and it was like done in a minute. So this was really nice. Done DB, exactly. Get things done. So we are ready. We have the Parquet file. We can query it. Okay. So I have this table. And so this is some, I want to move it a bit more up. Yeah. This is a train, actually, right? And at this timestamp, at this stop, which I don't know what it is, it had like 2 minutes delay on arrival. And that's a problem that I don't know the name of the stop. And that's something really nice on DuckDB as well. Same select statement, but I join it on a table which is in Postgres. So I'm joining Parquet files on Postgres table in one statement, and it will just work, which is also really nice and flexible, right? And I have the same table, but this time with actually some understandable names of the stops. So this is it, like I can ask the data something, and the last step in the pipeline, which you might want to remind me about, is I said it's in Azure Blob Storage, and it actually is. So I can just locate the files with this like little path starting with Azure, and I've already provided the credentials, so this should work now. There are no credentials. So I'm lucky I just used the dev secrets here, so I can actually show it to you. And now let's go back. Ta-da! So this just described the table that's located on my Azure Blob Storage. And this table already has like tens of millions of rows, and I could get the description like pretty fast. So to repeat, I have Postgres. I can create this little simple data lake really fast and just offload the data. It's cheap, and then I can analyze it on my laptop, ask queries, and then I can actually visualize it at the end, which we did. And I will show you this little example here. It's the path from Davidska to Prašný Most, which is of particular interest to the ROPID, the transport organizers. And this is the history from January to May. And these are the delays in seconds, right? So whatever is under 1 minute is green. Whatever is above is red. And this is median values, right? So at least 50% of the connections that day on this route finished faster than 1 minute. And so clearly you can see that there has been some changes from around here, right? The delays are getting stronger with some outlier here. And this is something that they really want to know, because they do use this to support some of their arguments to change the traffic, to change the signaling maybe on the route, and to argue about change of schedules, because sometimes it just makes sense to change the schedule, and this delay is completely fine, and people get more precise information. So that's it. Thank you for your attention, and I'm happy to answer your questions.